Hello, so in today's class we will look at problems of applied maximum and minimum. So we'll see word problems where you need to define a function, then for that function you will be finding the maximum and minimum. Now the problem can be mainly of two types. So the problems that reduce to maximizing or minimizing a continuous function over a finite closed interval. So your problem can reduce to finding maxima or minima in a finite closed interval, or there can be problems where you will be maximizing or minimizing the function over an infinite interval or a finite interval that is not closed. So the endpoints may or may not be included, or you can have infinity as the endpoints. You can have plus infinity or minus infinity, or limits or intervals which are one-sided with infinity. So those are the main optimization problems. So we will just see few problems. So with that we will wind up the first module. Okay, so let us see an example. So the first example is a garden is to be laid out in a rectangular area and protected by a chicken wire fence. What is the largest possible area of the garden if only 100 running feet of chicken wire is available for the fence? So here you need to find out, so you need to lay down a rectangular area. Fence, you need to form a fence which is in the rectangular shape, and the length of the wire which is available is 100 running feet. So for a rectangular area, so you need to find out what is the largest possible rectangular area. So here you need to maximize the area under the condition that your perimeter must be equal to 100. So let us define the variables. So let me define x to be the length of the rectangle and y as the width of the rectangle. So area is given by length into width. So the function which you have to maximize is, so you need to find the largest possible area. അപ്പോൾ maximize ആണ് ചെയ്യേണ്ടത്. maximize ചെയ്യേണ്ട function എന്ന് പറയുന്നത് a equal to xy. Now we know only how to find the maxima or minima for single variable function. So here a depends on the two quantities x and y. അപ്പോൾ അതിനാണ് നമുക്ക് ഈ restriction തന്നിരിക്കുന്നത്. So here the total length of wire used is 100 running feet. That means your perimeter will be 100 feet. So you have 2x plus 2y, that will be the perimeter of the rectangle. So if these are the dimensions of the rectangle, perimeter will be 2x plus 2y. But 2x plus 2y എന്ന് പറയുന്നത് 100 വരും. So that gives y must be equal to 50 minus x. Now we can replace y in terms of x. So therefore the problem now reduces to maximizing a equal to x into 50 minus x, and here x can take only the values. Upon y യുടെ value, so since y is the width, y must be always positive. So x can take only maximum value 50. y positive ആവണമെങ്കിൽ so x has to lie between 0 and 50. So the problem reduces to maximizing 50x minus x square in the interval, closed interval 0 to 50. Okay, and ഇനി ബാക്കി നമ്മൾ നോർമലി ചെയ്യുന്നത് പോലെ ഫംഗ്ഷൻ്റെ ക്രിട്ടിക്കൽ പോയിൻറ്റ്സ് കണ്ടുപിടിക്കുക. So using the second derivative test you can find out what is the maximum point. So when you take the first derivative, you will get 50 minus 2x. So the critical point will be 50 given by 50 minus 2x equal to 0. So that is x equal to 25. So when you take second derivative is minus 2, so which is less than 0, so x equal to 25 will be maximum point. Second derivative negative ആയതുകൊണ്ട് അത് maximum point ആയിരിക്കും. So therefore the required value of x will be 25. ഇനി x 25 ആണെങ്കിൽ y value will also be 25. So therefore the largest possible area is obtained when x is equal to y equal to 25. So it must be a square where the dimension is 25. So that is how we have solved the problem. Okay, now let us look at one more question. So an open box is to be made from a 16-inch by 30-inch piece of cardboard by cutting out squares of equal sides from the four corners and bending up the sides. So what size should the squares be to obtain a box with the largest volume? So here you are given a 16 by 30 inch cardboard. ഇനി കാർഡ്ബോർഡിൻ്റെ 4 സൈഡിൽ നിന്നും നമ്മൾ സ്ക്വയേഴ്സ് കട്ട് ചെയ്യുന്നു. യു ആർ കട്ടിങ് ഔട്ട് ഈക്വൽ സ്ക്വയേഴ്സ് ഫ്രം ഓൾ ദി 4 കോർണേഴ്സ് ആൻഡ് യു ഫോൾഡ് അപ്പ് ഓൾ ദി ദീസ് portions, so that will give us an open box. So our aim is to maximize the volume of the open box. So you need to find out what is the value of x. അപ്പോൾ നമ്മൾ കട്ട് ചെയ്ത സ്ക്വയറിൻ്റെ ഡയമെൻഷനാണ് നമുക്ക് കണ്ടുപിടിക്കേണ്ടത്, such that you get the largest volume. So here you need to maximize the volume. Okay, so let us now write down the volume. Now the dimension of the cardboard is 16 by 30 inch. This side represents the 16-inch side and this is the 30-inch side. Now you are cutting square of dimension x from all the 4 corners. So therefore this new length becomes 16 minus 2x. അപ്പോൾ 16 എന്ന് 2 കോർണറിൽ നിന്ന് x റിമൂവ് ചെയ്യുന്നു. So this new length is 16 minus 2x. Here it will be 30 minus 2x. So your box will have volume. So you have length, breadth and width, length, breadth and height. Okay, so volume will be 30 minus 2x, then 16 into 16 minus 2x into x. ഈ height എന്ന് പറയുന്നത് x വരും. This will be the height of the open box. So therefore our aim is to maximize the volume. So volume will be given by x into 16 minus 2x into 30 minus 2x. So upon multiplying, this will become the function. So you will get 4x cube minus 92x square plus 40 minus x. Now usually ചെയ്യുന്നത് പോലെ തന്നെ ചെയ്യുക. ഇനി നമുക്ക് this dimensions must be always greater than or equal to 0. So x must be greater than or equal to 0. അതുപോലെ 16 minus 2x must be greater than or equal to 0 and for 30 minus 2x must be greater than or equal to 0. So that gives x must be less than or equal to 8. x less than or equal to 8 ആണെങ്കിൽ മാത്രമേ ഈ ക്വാണ്ടിറ്റി പോസിറ്റീവ് ആവുള്ളൂ. So obviously here also x has to be less than or equal to 8. So if 16 minus 2x has to be greater than or equal to 0. So this must be positive ആവണമെങ്കിൽ and this must be less than or equal to 8 and greater than or equal to 0. So therefore x will take the value between 0 and 8 here. So now let us maximize this function. So find out the first derivative. So first derivative is okay, we'll get 4 into 120 minus 46x plus 3x square. So that is 4 into x minus 12 into 3x minus 10. So upon equating to 0, so you will get x equal to 12 and 10 by 3. Now x cannot be 12 because dimension negative avum, so 12 possible alla. So now the critical value which is possible is 10 by 3. Ini adu maximum aano alleyo nokka. For that find out the second derivative. Now second derivative value will be negative at that point, so therefore that will be the required value of x. So you can find out the second value. So you can see that will be negative. Okay, so therefore the required value of x will be 10 by 3, and this is going to be the volume. So the volume is 726 inch cube. So that is the largest volume possible.